get the prep work done again on the side here. So the nice thing that's on the right hand side, they are zero. They are zero. So the Laplace of zero is just zero. What we have to get is the right term for the second derivative. So as the Laplace of the x, lowercase x is the uppercase x. Laplace of the lowercase y is the capital Y. And for the second order, the second derivative, we'll come back, Josie. The second derivative, the second order start with the s to the power 2 of the capital X minus, and then the power get back down for the s. So s to the first times x0, which is the lowest order of the initial condition, and then minus s0, x prime at 0. You see kind of x in the opposite way for the order of the derivative for the initial condition, but for the s is the power starting from 2 and then 1 and then 0. Now, what we have, x at 0 is 0, x prime at 0 is negative 3. Then we have the Laplace of the second order or the second derivative of the x as s squared multiplied by x, and then negative s to the power 0 is 1, negative and negative positive. So it becomes s to the second minus 3. Oh, plus 3, sorry, plus 3. And then next one, the Laplace of the y double prime is s squared, the uppercase y, minus s to the first y at 0, minus s to the power 0, y prime at 0. The y at 0 is 0, y prime at 0 is 1. Then the Laplace of y double prime is s squared, uppercase y, and minus 1. Okay. Next one, we just go back to the problem, apply the Laplace transform to both sides of each equation. So just write out the form Laplace x double prime plus the Laplace of the x minus the Laplace of the y equals the Laplace of 0. Second one, the Laplace of the y double prime plus the Laplace of y minus the Laplace of x equals the Laplace of 0. And from what we got on the side, the Laplace of the x double prime, we have x squared times capital X plus 3 plus the uppercase x for the Laplace x minus the uppercase y for the Laplace y equals 0. And the second equation, x squared this is s uppercase y minus 1 and plus the uppercase y minus uppercase x equals 0. Okay. And next we just rearrange the term, regroup the x together, y together, similar to the way that we did in 4.9. For the like put in the order in a way that is easier to organize and manage. So for the group of the uppercase x, we have the s squared plus 1 as a coefficient of the uppercase x, and then minus y. The 3 is a constant. Oops, where did it go? Resume chair. And it's gonna be uh, moved to the right hand side to be 3. Okay, we just make it cleaner. It has just x and y together on the left hand side to be ready to eliminate one of them. See which one is easier to do it or less complicated to do it. And the second equation, right, in order to, since typically we put x as a first order, so gonna put negative x here. And then for the coefficient of the uppercase y is s squared plus 1 as well. The uppercase y equals number negative 1. So add 1 both sides, so it becomes the right hand side 1. Okay. Next, decide whether you want to eliminate x or y. And this one looks like both x and y have the same coefficient. We just pick and choose. How about we eliminate x this time? Are you guys okay with that?
Yep.
Okay, we're gonna eliminate x. This is the target. That means we're gonna have to multiply the second equation by s squared plus 1. Okay, s squared plus 1. Then we get, and then we add them up. We add them. So the x term gonna be gone. Now we have s squared plus 1. Looks like we have power 2 of s squared plus 1 of the capital Y minus the capital Y equals 3 plus 1, which is 4. No, this is negative 3. Sorry, what I did. I miss it. So negative 3 plus 1, this is negative 2. I'm wrong. So this is negative 3. See, I missed one side. It's going to affect a lot of terms here. Simply multiply all term by s squared plus 1. So it's going to be negative 3 plus s squared plus 1 because you multiply this to all term. Okay, that comes out to be s squared minus 2 for the right hand side term. Now simplify, because next step we're going to solve for y, the uppercase y. So collect the term. This one becomes s squared plus 1 square and then minus 1 as a coefficient of the uppercase y equals s squared minus 2. It gets more complicated than the previous problem. So to solve for y, same thing, divide all by the coefficient of the y, just to make it less complicated. Simplify what we have as a coefficient of the y here. Expand the power 2 of s squared plus 1. That would be s to the fourth plus 2 times s to the second plus 1 minus 1 is not too bad after you simplify it. So it becomes s squared plus, no, s to the fourth plus 2 times s squared. So I'm going to factor s squared out to be s squared times s squared plus 2. Okay, not too bad, right? Now I'm going to add another slide. So now our capital Y will be in the form of the s squared minus 2 for the numerator and divided by the simplified form of the coefficient of the capital Y, which is s squared times s squared plus 2. Mhm. And we call the uppercase y is the Laplace of the lowercase y. And when you find the y, that means you find the inverse Laplace of the uppercase y, or find the inverse Laplace of the fraction on the right hand side. Again, we're going to need the partial fraction. So this partial fraction as the power 2, and this is the irreducible quadratic. So we should end up with divided by s, something divided by s, something divided by s squared, plus something divided by s squared plus 2. If you recall the partial fraction technique in Calc 2, the s squared, that means you have s minus 0 to the power second. So you have to expand into the sum of the partial fraction from the lowest power up until the power 2, which is the lowest power 1, power 2, and then another factor. And then each one, the s to the power first, that's a linear. So we're gonna do the constant a. S, this is considered the linear term with the power 2, still the constant b, and the s squared plus 2, we're supposed to have the linear form as the numerator. We're supposed to have c times s plus d if we do it by hand. So this is the setup. Okay, now I'm gonna let you guys use symbol lab again, find the coefficients a, b, c, and d for these partial fractions. Yeah, type in the s squared minus 2 for the numerator and s squared times s squared plus 2 for the denominator.
So Symbolab says A is 0.
Okay, let me uh put in. Thank you, Noah. Keep
Mhm.
going. A is
It says
0.
A is 0, and then it
Mhm.
says B is -1,
Okay.
and then it says C is 0,
Okay.
and then D is 2.
Okay. Perfect. Thank you. How about you, Andrew and Josie? You got the same?
Yep, that's what I got.
Okay. Thank you. So
Yep.
now, awesome. So fr- gonna rewrite it. The capital Y is this term is gone, and the over 2 is gonna be negative 1 over s squared, and the last term we have 2 divided by s squared plus 2, and then apply the Laplace transform. So then, since this is the Laplace of the lowercase y, so the y is the inverse Laplace of, I put negative as a coefficient, negative inverse Laplace of 1 over s squared plus this time just easier for us to adjust because we see the power 2 of the s plus the number. So either side cosine will come out. So the coefficient just get it out of the way for now. Have 1 over s squared plus I'm going to rewrite 2 as square root 2 squared just to make the form ready to go. And if you recall the theorem in 7.1, um, for the power, the Laplace of t to the power n is n factorial divided by s to the power n plus 1. And the Laplace of the cosine kt is s on the top because cosine the s, and then the bottom is s squared plus k squared. The Laplace of the sine of the kt is k on the top, and then the bottom is square plus k square. Sine and cosine have the same denominator, but the cosine has a s, the sine has the number which is the k number. That's the point that I write the 2 in terms of square root 2 squared. So in this case, k is square root 2, and the numerator, like no s, right? No s. So that means it's gonna come out as a sine for the inverse Laplace transform of the second term. Now, to make it fit into this form, we're gonna need k on the top, right? So we're gonna multiply both top and bottom by square root 2. And for the first inverse Laplace, which is 1 over s squared, this is the same as s to the power 1 plus 1. This way, we can identify n equals 1. For n equals 1 factorial is the same as 1. So we don't have to adjust anything for the first inverse Laplace. You guys okay so far?
Yep.
Okay, that's good. All right, so now our solution y is negative, and since n is 1, can be t to the power 1 or just negative t for the inverse Laplace. And the second, we keep we keep square root 2 as the numerator of the s squared plus square root 2 squared, and then the bottom square root 2, it's treated as a coefficient, so it will be joined with the 2 out front. So become 2 over square root 2. And the inverse Laplace now give us the sine of the k, which is square root 2 times t. Okay, so this is the solution y. We have one solution out. And you can simplify 2 over square root 2 as square root 2. So either one, so I'm fine. So at this point, so we done the main process. So this is the y. And then the rest of the process is to find the x value or the solution x. And again, we have to go back to the form that we got. Which one is easier to solve for x? And looks like the second one is easier. The second equation in the form of the capital X and capital Y. Okay, so
Real
that's
quick,
why.
I'm curious.
Yeah, yeah.
If you wanted to, could you do it the same way that we did it earlier with solving systems and like take the derivative and integrals and stuff?
You you can do that. You can go back to the earlier, but this objective is to use the Laplace transform.
Yeah, okay, just checking.
Yeah, you can because some problem is less complicated to do that way. Yeah, but the instruction of this problem is to use the Laplace transform. So we just stick with the Laplace transform. And the the tricky part of that way is you can, yeah, you can use this for the kind of the problem that we've been working on. But in the case of the right hand side or the non-homogeneous part in the unit step function, in some other form that you cannot use the method that we did in chapter 4. Remember, if you have the non-homogeneous with the right hand side is not falling into the form of exponential polynomial or trig. So in some other form, you, it's kind of, you are stuck. You cannot go further with the undetermined coefficient. You have to find another method, and that would open to Laplace transform to solve that kind of problem.
Okay, just wondering.
But you are right. You can always go back to use the derivative. And as you see, Laplace transform has nothing to do with derivative, antiderivative at all. It's purely algebra, right?
Yeah.
that's 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 interesting. But if you like algebra, I think you would have fun with Laplace transform. Are you having fun?
Yeah, it's not too bad.
Not too bad. That's a nice way to say it, Josie. Thank you. We're gonna use the second one. The second one, which is put on a note here. Or I have to change the pen. So from negative capital X plus s squared plus 1 capital Y equals 1. So that means the uppercase X is move term over and then move 1 over, gonna be s squared plus 1, the uppercase Y minus 1. Okay, that means what we have, the s squared plus 1, s squared plus 1 multiplied by the uppercase Y that we did found earlier, which is this form. Or it might be convenient to use the one that we did before the partial fraction. I will use the one before the partial fraction because we have to regroup them, untangle them, and then use the inverse Laplace transform again, another layer. So that's, now I see why Josie wants to do the derivative. I'm gonna go back to the form that we did before the partial fraction. Okay, and then subtract it by 1. Then gather them as s squared, s squared plus 2, s squared plus 1 times s squared minus 2, and then minus, since 1 means 1 over 1, make it the same denominator. So multiply both top and bottom by s squared times s squared plus 2. Simplify, simplify, simplify to get negative 3s squared minus 2 divided by s squared times s squared plus 2. Uh, uh, could you do that real quick? Put in the symbol lab, find the partial fractions, and it's going to be the same pattern as a over s plus b over s squared plus c s plus d divided by s squared plus 2.
So I got on Symbolabs. A is 0,
Okay, A is 0. Oops, I hit the wrong one. Sorry. A is 0. Sorry. Yeah, go
It's
ahead.
all right. B is -1,
B is -1,
C is 0,
and D is
and D is -2.
-2. Awesome. Thank you. And then since the x is the Laplace of the lowercase x, that means the lowercase x is the first one is gone. Next one is the inverse Laplace of 1 over s squared. And the second, it's -2. It come out almost similar to the one that we got for the y, right? So -2, and then the inverse Laplace of 1 over s squared plus 2 or square root 2 squared. And it should give us -t minus 2 over square root 2 times sine of square root 2t.